All right, Algebra 1, we're going to start our 2-2 notes here with 2-2A. This is where we're starting all of our factoring stuff. So we're going to start this by factoring out a greatest common factor. So before we do that, let's just review this greatest common factor concept. This is something that we've already talked about, so we'll just review this. So remember, if we have three terms here, 50x, 15x to the third, and 25xy, we want to find the greatest common factor here. So we look at our numbers, 50, 15, and 25. And we want to know what is the biggest number that will divide into each of them evenly, 50, 15, and 25. So what I usually do is I start with my smaller number, and I look at my factors for 15. So the factors for 15 would be 1 and 15, and then 3 and 5. And I want to know which of these three will divide into all of these. Which of these four numbers will divide into all of these three evenly. So 15 doesn't go into 50 or 25. So then I go down to 5. 5 goes into 25 and 50 evenly. So I know that has to be my GCF. So it's 5. You can already see I have the correct answer written here. But then I go on to my variables. And if you remember for GCF, your variables, it's the smallest power. So I have a 1 and a 1 here, and this one is a third power. So the smallest power for x is 1, and then you may be asking, well, why don't I have a y here when there's a y here? And that's because the 50 and the 15 do not have a y, which means they would have like a y to the 0, and that would be your smallest power for y. So we don't include a y as part of our answer if it's not in all of our terms. All right, now we're going to use that same concept here when we are doing these other examples. The only difference is we're going to have to do one more step, one extra step, and divide that out. But the first thing we have to do is actually find it. So right here, the first step is to find the GCF, and then we will divide it out. And as you can see here, this is the opposite of the distributive property. So back in, what was that, whatever, 2-1C or 2-1D or whatever, one of those sets of notes where we took one monomial and we multiplied that through by 2 or 3 terms. That is basically the opposite of what we are doing here. Okay, so this is why, again, it was so crucial that if you did not understand what you were doing on those notes that you asked, because now we're doing the opposite of that. So here we go. Let's just get started on some of these notes, and we'll see how you do. So we want to factor these completely. So this is kind of a basic one, and they do get more complicated than this, so just follow along what I'm doing here. We'll just do one step at a time. Let's look at your numbers, 5 and 15. Find your greatest common factor. That's always our first step, find the greatest common factor. What's the biggest number we can divide out of 5 and 15? Well, that's a 5. The biggest number we can divide into 5 and 15 is 5. And then we just look at our smallest power for x. Well, this is a 1. This is a 2. The smallest power there is 1, so just bring out the x. And we look at our smaller power for y. Again, this is a 1. This is a 2. Smallest power is a 1. So that's the GCF. Okay, but we're asked to factor now, so we got to take this one step further, and we're actually going to factor that out. So what that means is we're going to take the GCF out front, and we want to see what's left after we take that out of each term. So what that means is when we take it out or factor it out is actually divide it out. So 5 divided by 5 is 1. You can put a 1 there if you want to, but I'm not going to. Now if I started out with x squared, that's like starting out with 2 x's, right? Like x times x. I took one of them out here, so there's still 1 left. I started out with 1 copy of y, but I took that out, so there's no y's left. So my first term is just an x. Plus, right, I got a plus sign here, so plus. Go back to your numbers. 15 divided by 5 is 3. Okay, remember 5 divided by 5 is 1, so there's still like a 1 here. And then x, I started out with 1x, but I took that 1 out. Y squared means like 2 copies of y, so y times y. I took one of them out right here, so there's still 1 left, so 1, y, and that's my final answer. And now you could do like we did in that other section. So this is your final answer right here. We're done. Okay? I'm finished with the problem. That's it. I'm done. If you wanted to check your answer, what you could do was we could go back to what we did in that section. I think it was 2-1C, I'm not positive, but it was one of those sections. We could take this and we can multiply it through. 5xy times x is 5x squared y. 5xy times 3y, 5 times 3 is 15. xy times y is xy squared. So you can multiply that back through and you should end up with what you started with. That's how you know you did it correctly. All right, let's move on to the next one here. Now I have the GCF here. Okay, I have the GCF done, but what I'm going to do is I'll divide it out now. All right, so my greatest common factor, 18 and 6. The biggest number I can take out there is a 6. Smallest power for x is an x squared, so I bring the x squared out. Smallest power for y is a y to the first power, right? So I bring that out. All right, now it's time to divide. 18 divided by 6 is 3. I started out with x to the third power, which again, remember that means there was 3 copies of x. I took 2 of them out, so there's still 1 left. And y squared meant there were 2 copies of y, but I took 1 out, so there is 1 left. Minus 6 divided by 6 is 1. I took out the x squared and I took out the y. Now this is the only case where you need a 1. Because a lot of times what people do is they say, well, I took a 6 out, I took an x squared out, I took a y out, so there's nothing left, and they close the parentheses and they say I'm done. But if I multiply this through here, I don't end up with what I started with. Okay, so let me back up a step here, because you have to make sure that if you multiply this through, you end up with what you started with. So this is the case where you need to have a 1 there. We need to have a filler. If there's 2 terms, right, here's 1 term, here's 2 terms, there needs to be 1 term, 2 terms in our answer, okay? So just keep that in mind. That is a common mistake that I see happen a lot. But here's your final answer. This is what we should get for this problem. All right, let's move on to C. I have this one done for you, so let's just follow along here and you can write this down. GCF for 6 and 9 is 3. Smallest power for x is, for the x's is just x. So I take the 3x out and then I start dividing. 6 divided by 3 is 2. I started with x squared, which meant 2 copies of x. I took 1 out. There's still 1 left. Bring down the minus sign. 9 divided by 3 is 3. I started with an x, but I took that x out, so no x's left. So there's your final answer for C. All right, now D, this is where it starts to get a little bit more complicated, and people look at this and they're like, wow, there's a lot of stuff happening here. There's a lot of variables, exponents, the numbers are bigger. But the process is exactly the same. Don't get confused, and this might look a little overwhelming, but it's the same type of problem, okay? So let's start with our numbers, okay? 40, 25, and 50. I want to know what is the biggest number that will divide into those 3 evenly. So let's start with the smallest number. Let's start with 25. Well, 25 only has 3 factors. Well, other than 1. We're just going to ignore 1, okay? Because 1 will go into everything. So 25, all right, 25 goes into 50, but 25 doesn't go into 40, so that won't work. The only other factor that works with 25 is 5, so it has to be 5. Okay, 5 goes into 40 evenly, 5 goes into 25 evenly, and 5 goes into 50 evenly, so that'll work. All right, so then I look at my variables. What's the smallest power for x? Well, there's a 4, there's a 2, and there's a 3. Smallest power is a 2, right? That's pretty simple. Smallest power, that's a 2. What's my smallest power for y? 3, 2, 2. Smallest power is a 2. That's it. Okay, there's my GCF. Now we're just going to do our dividing. So 40 divided by 5. 40 divided by 5 is 8. And now what we're doing is subtracting. Remember when we divided with our, remember this is why we had to do all of our exponent rules before we did this stuff. So when we're dividing, x to the 4th divided by x to the 2nd, we just subtract. 4 minus 2 is x squared. And then y, subtract, 3 minus 2 is 1. So you could put a 1 there, but I'm not going to do that because we don't need it. 25 divided by 5 is 5. And then x squared, I took the x squared out, so no x's left. Started with y squared, I took the y squared out, so no y's left. So all I'm left there in the middle is just 5. That's all I'm left with. Minus 50 divided by 5 is 10. I started with x to the 3rd. I took x squared out, so I'm still left with an x. but then I started with a y squared, took y squared out, so no y's left, and there's my final answer. Okay? So dividing your numbers and subtracting your exponents. Okay, it's just the opposite of what we did last week where we multiplied the numbers and then added the exponents, right? It's just the opposite. Divide the numbers, subtract the exponents. All right, E and F, I have these two done for you, so just follow along with me. Feel free to stop the video, rewind, whatever. Pause the video while you're writing them down because I'm going to go through these kind of quickly, but just follow along with me here so you can get these notes copied down here. So we have no numbers, first of all. The numbers out front here, these are just a 1, so we're not going to write the 1s down in our answers. So all we're worried about here are just the variables. So smallest power for A is 2, and the smallest power for B is 3. So a squared b to the third comes out front, and then we just start subtracting our exponents. So if I started with an a squared, but I took an a squared out, there's no a's in that first term. B to the fifth minus b to the third leaves me with b squared. Second term, I started with a to the third. I took out a squared, so I'm left with an a to the first. And then I have b to the third, and f is kind of like d. It has 3 terms like this. So if we jump ahead to f here, again, it may look a little complicated with all the numbers and variables and everything like that, but just follow through. Your numbers are a little bit bigger, but again, same thing. 80, 64, and 36. Start with your smaller number, 36. So your factors for 36, okay, is 1 and 36. We have quite a few more to work with here, like 2 and 18, 3 and 12, oops, 4 and 9, 6 and 6. I don't think I'm going to be able to fit 6 in there. There we go. But anyway, if we look at this, so 36 doesn't go into those, doesn't really work there. So, I mean, well, yeah. If we go on to 18, that doesn't work. 12, I think we have to go all the way down to 4 until we find one that'll work in both of those, right? So, yeah, like there's not really, 64, you basically have like 8 and 8, 4 and 16, 2 and 32. So not a whole lot to work with there. So we got to go down to 4 for our greatest common factor here. And then we're looking at our variables for h. Smallest power for h is 1. Smallest power for j is 1 in this first term and the last term. So our GCF is just 4hj. And then when we divide that out, excuse me, 80 divided by 4 is 20. And then it started with an h, took that out, started with j, took that out, so they're gone. 64 divided by 4 is 16. Started with h squared, took one h out, so we were left with h. Started with j squared, took one j out, now we're left with j. Plus 36 divided by 4 is 9. We started with h squared, we took one h out, so there's still an h left here. And then we started with j, but we took one j out, so there's no j left there. So that is your final answer. Okay, so again, this is just the opposite of what we were doing last week. So divide the numbers, subtract your exponents, where last week we were multiplying the numbers and adding the exponents. So it's just the opposite. But again, if you need to rewind the video, watch those examples again, and then let me know if you have any questions. Just send me an email, like always. Send me an email, send me a private comment, and I will get back to you and answer your questions.